AB Calculus, Note Card 33, Finding Extrema on an Interval. This is the 33rd lesson, inspired by Stacy McMullen, formerly of the Dallas Independent School District, who developed this note card system. And this is a follow-up lesson to lessons 31, which was for the extreme value theorem, and lesson 32, which was essentially looking at a calculator to examine and look at what a relative maximum and a relative minimum were. Okay, critical numbers. Let f be defined at c, or x equals c, if f prime of c equals 0, or if f prime is undefined at x equals c, then c is a critical number. To find the critical point, find the y value of the function at c, or f of c. And so the critical point we can write as a coordinate pair, which would be c, comma, f of c, and it is the x value, c, that is going to be the critical number. Just abbreviate critical number, okay? Now, to find absolute extrema values of f in the closed interval, now if we have parentheses surrounding the a and b instead of brackets, the extreme value theorem would not apply for that. Now, first step, draw a t-chart. And this t-chart, what we're going to do is the process called, not mentioned here, is the candidate test. Candidate test. And we call it the candidate test because each place where we could have an absolute maximum or minimum becomes a candidate. First, write the endpoint values in the x column, and I like to put the lowest value or a value here and the b value or highest value down here, input values, and find the critical numbers of f in this open interval from a to b, and also write them in the x column. So you'd write them here. I would write them between the a and the b, and then evaluate f of x for each critical number and endpoint, and the smallest y value is the absolute minimum, and the greatest y value becomes the absolute maximum over the interval. Now we're going to look at some problems demonstrating what we need to do. Determine the critical points for g of x equals 2x cubed plus 3x squared minus 12x minus 1. And now we're not talking about, in the context of this problem, finding the absolute maximum or minimum. We're looking at finding the critical values in between the endpoints. And the endpoint, we don't have endpoints because we have a domain of all real numbers. Determine the critical points. Well, to find the critical points, we're going to find where the first derivative, g prime, is equal to 0. And to find what that is, we have to find that first derivative, which for this g of x is going to be 6x squared plus 6x minus 12. Okay, just using the power rule for this. And now we set this equal to 0. G prime of x is equal to 0. And we're going to factor out a common factor of 6. And we have 6 times quantity x squared plus x minus 2. And then if we divide by 6, we can essentially get rid of this 6. And we're left with 0 is equal to, and we're going to find the factors of what's remaining here, this x squared plus x minus 2. And we know the factors of x squared are going to be x and x. And we have negative 2, so one's going to have to be minus, and one of these signs is going to have to be plus. And 2 is what we're looking for, but we're looking for plus x, so we're going to have this 2 be over here, and this 1 over here. And so using the zero factor property to find our critical numbers, we say x minus 1 is equal to 0, and x plus 2 is equal to 0, because if either of these factors is equal to 0, there we have the solution. So x is equal to 1, and x is equal to -2. So what these become are the critical numbers. Okay? And we're going to use these critical numbers to help us determine what the critical points are. And the first one, we're going to use that 1, so we're going to find g of 1, and we'll just substitute in g for x in the original function, so 2 times 1 cubed plus 3 times 1 squared minus 12 times 1 minus 1. And we're going to get 2 times 1 cubed is 2 plus 3, and then minus 12, and then minus 1. So we're going to have g of 1 is equal to 5 minus 12, that's -7, minus 1 is -8. So we would say our critical point is going to be the coordinate pair 1, -8. Okay, now we're going to find, use our other critical number, which is -2, so we're going to find g of -2, and that's going to be 2 times -2 cubed plus 3 times -2 squared minus 12 times -2, and then we have minus 1. And for that, I guess we're going to work to the right. We get -2 cubed, that's going to be -8, so we're going to get -16. And then we have plus 12, that next one will be plus 12. And then we have plus 24. And finally minus 1. And so g of -2 comes down to -16 plus 12, that's -4, plus 24 is 20, minus 1 will be 19. So our critical point in this instance is going to be the coordinate pair -2, 19. Okay, let's go on to problem 2. This time we have an actual AP test problem. It is a calculator problem. For f prime of x equals cosine squared x over x minus 1/2, how many critical values does f have on the interval from 0 to 10? And we're looking at an open interval here. Okay. So I previously entered in my T-Inspire CX calculator the function, and the way we have to write cosine squared x, we don't put, as in the notation, the squared. We have to square the whole cosine x. And so graphing this, we press enter, and because of the scale, we're not able to see very well close to the x-axis here, but we can see that we have a vertical asymptote at x equals 0, which we'd have to expect. So I'm going to change the view on this window zoom, and oops, where's that window zoom? There we go. Window settings, and I'm going to go change my y minimum to -1 and my y maximum to 1, and tab down. And so here we have a better look at what's going on. Now, if I'm not careful, that says how many critical numbers? Well, there's a little relative minimum, relative maximum, relative minimum, 3, 4, 5, 6, and undefined, okay, 7, 8, 9, 10, 11, 12. So 12. But we got to take a close look at what this means, okay? The definition of a critical number is where f prime of x is equal to 0 or undefined. So if we look carefully, I see it only is 0 where f prime, this is the graph of f prime of x, so only where the x-axis is being touched do we have an actual critical number, or is undefined, which is where at x equals 0 we have this vertical asymptote. So the vertical asymptote 1, and then this one close to 1, and then this one between 2 and 3, and this one between 3 and 4. So our answer to this question is 4 critical values. And it says critical values. Okay, we're going to use the same. This would show up in a as a multiple choice problem. So we got to read carefully and understand what is going on with this f prime of x as opposed to the f of x. Next, 3, find the absolute extrema values on f of x equals 9 times quantity x squared minus 3 over x cubed for the interval between -4 and 1. And in this instance here, we're asked for the extrema values. So the first thing I'm going to do is come over here and actually make that table. And we're going to put x here and f of x. And then our endpoints are going to be -4 for our low value and -1 for our highest value. And any critical numbers or numbers we see are going to be in between here. So now I'm going to rewrite this f of x here. F of x is equal to, we're going to distribute this 9 to inside the parentheses. So we're going to have 9x squared over x cubed minus 9 times -3 is going to be 27 over x cubed. And further simplifying here, we're going to have this 9x squared divided by x cubed is going to be 9 over x, and then we have minus 27 over x cubed. And finally, we're going to rewrite this function in calculus-friendly form, which is going to be 9x to the -1 power minus 27x to the -3 power. Okay, so that's all a rewrite so far, this line. Now f prime of x, what is f prime of x? F prime of x is going to be, we take that -1 times the 9 out front, so we're going to have -9, and we're going to have x to the -2 power because we subtracted. And then for this other one, the other term, we have -3 times -27 is going to be positive 81, and that's going to be x to the -3 minus 1 power, or -4. So what we have here is, just rewriting this, we're going to have 81 over x to the 4th power minus 9 over x squared. And now we can set this equal to 0 to find our critical numbers. So 0 is equal to 81 over x to the 4th power minus 9 over x squared. And we can divide both sides of this by 9. And for that, we're going to get, coming to the right here, 0 is equal to 9 over x to the 4th power minus 1 over x squared. And now I'm going to kind of work here to the left. So we can set 1 over x squared. What we're doing is we're adding 1 over x, negative 1 over x squared, 1 over x squared to both sides, equals 9 over x to the 4th power. And continuing our solution, I can turn each of these fractions upside down and get x squared equal to x to the 4th over 9. Okay, and so now we can cross multiply that 9, and so we get 9x squared equals x to the 4th power. Okay, and taking the square root of both sides here, we have square root of 9x squared is equal to square root of x to the 4th power. But when we take the square root, we're going to get a plus or minus. So we have plus or minus, and working to the right, we get square root of x to the 4th power, which is x squared, is going to be equal to plus or minus the square root of 9x squared is 3x. And finally, we can divide each side of this equation by x and have x is equal to plus or minus 3. And in this closed interval here, between -4 and -1, the only one that applies here is x equals -3, which we're going to put right over here, between the -4 and the -1. And so we just need to go ahead and plug in our values here. And I'm going to do this below here at the right. We're going to say f of -4, which might be the most complicated one of these. Well, we have 9 times. We have a -4 squared minus 3 over -4 cubed. And working to the right here, -4 squared is 16 minus 3, that's going to be 13. So we have 9 times 13 over, in our denominator, we have -4 cubed. It's going to be -64. And 9 times 13, let's see, 10 times 13 is 113. So 9 times 13 is going to be 13 less than 130. So we have 117. I'll say -117 64ths. Okay, so that's kind of close to -2. So I'm going to put -117 64ths. And I think the others aren't going to be as hard to figure out. So f of -3. So this is a candidate test, right? We're listing the candidates. So we're going to have 9. This is our critical value here. We have -3 squared minus 3. And then down here we put in -3 cubed. And working to the right, we have -3 squared is 9 minus 3. So we're going to have 9 times 6. And that's going to be over -27. Okay, that's going to be -54 over 27, or -2. So I'm going to put -2 right here. And I'm thinking this number here for -4 is going to be a little bit, not quite -2. So between these two, that would be there'd be a minimum at x equals -3, okay? And finally, f of -1 is going to be 9 times, we have -1 squared minus 3 over -1 cubed. And working to the right, we're going to have 9 times, well, we'll have 1 minus 3 or -2, so we'll have 9 times -2, and we're going to have over -1. And so that's going to simplify, the negatives will cancel out, we're going to have 18. Okay, so we have 18. So we say there is a absolute max at, let me see, we got to work carefully. Absolute max of 18 where x is equal to -1, and we have absolute minimum of -2 where x is equal to -3. Okay. Next, problem 4. The absolute maximum value of fx equals x cubed minus 3x squared plus 12 on the interval, on the closed interval from -2 to 4 is, we don't know yet. We have a continuous function here. There are no breaks in that interval. So we know the extreme value theorem is going to apply. Again, similar to what we did in problem number 3, we're going to put f of x, and put our endpoints in place, which first one is -2, the last one is 4. Any critical numbers will go in between. So we're going to say f prime of x is equal to 3x squared minus 6x. Okay, that's going to be it. And we're going to set that equal to 0. So we say 0 is equal to factoring out, we can factor out 3x times x minus 2. So we have critical numbers solving. We have x is equal to 0, and also x is equal to 2. So now we're going to place our critical numbers right here, 0 and 2, and then we're going to evaluate and figure out our absolute maximum value. And the 0 will be easy to find, because if we just set f of 0, it's just going to be our y-intercept, or 12, so that's going to be easy. Now we're just going to go down the list. F of -2 is equal to -2 cubed minus 3 times -2 squared plus 12. So we're going to get -8, and then we're going to have minus 12, and then we're going to have plus 12. So minus 12 and plus 12 cancel each other out, so we're going to get -8. So -8, so we know our maximum value is not -8. Now we're going to find f of 2 equals 2 cubed minus 3 times 2 squared plus 12. So we're going to get 8 minus 12. Let's put 8 minus 12 plus 12 is going to be equal to 8. Okay. So far, our absolute maximum value we've found of the candidates is going to be 12. And finally, we're going to take f of 4, examine our last candidate here. And for that, we're going to get 4 cubed minus 3 times 2, oops, I said, I'm going to put 4, okay, 4 cubed minus 3 times 4 squared plus 12. And for this, we're going to get 4 cubed is 64. And then minus 3 times 4 squared. 4 squared is 16 times negative 48. And then plus 12. And that's going to be 64 minus 48 is going to be 16 plus 12 is equal to 28. So 28, here we go. So we have absolute, make a conclusion, absolute maximum of 28, where x is equal to 4. So there we are. I hope this lesson's been helpful to you. Good luck, and thanks for viewing.